So in this video, we will try to study about reference variables and pass by reference. Okay, I'm saying about reference variables. Reference variables. Yeah, we want to say about this. Let's see what they are basically. Okay, so let me explain it to you by first taking this small example. Okay, first let me write this small code. Okay, so hash include iostream using namespace std int main. Okay, and as I'm creating here I and whose value is 10, and I'm creating even j whose value is basically what is in the I, and I'm saying I plus plus, and I'm saying cout I and cout j. Let's see that we are still doing till this part. So till this part, what would have happened? What would have happened? Let's see. So till this part, what would have happened? Tell me. And this line, I. Okay, you want I. Let's create I at 700. Let's mark that in my symbol table. That I is basically created at 700, whose content is basically 10. Okay, and j equal to I. So okay, j, create a j whose address is 800. Instead of that, you're trying to actually copy the value of I. So what is I? I is 10, so put the value 10. I plus plus. Okay, I plus plus, great. And here even one more content is being made. One more like address. One more entry has been made because of this, right? Okay, now I plus plus, it means go here and make it increase it by 1. Okay, next print I. So if you see, if you print here I, then I will be 10, and if you print j, j is basically 800, so 10 will be printed, right? So here 10 will be printed. Everyone knows it, right? So let's see, we're getting this right. So let's see, we're getting this or not, and we are getting this right. Okay, now I would like to tell you guys something about reference variables. Okay, so let's again rewrite these things. Okay, so let's say right, let's say I'm writing here something like after this lines I'm going to write here int k equal to I. So what is the value of I value is right now 11. Okay, 11 will be printed here, copied here, and let's say this k is actually made it 850, so one entry will be made here at 850, right? Okay, so let's not do this, and instead of doing this, let's do something. Let's put an ampersand sign here. If you are putting an ampersand sign here, what basically happens is ampersand sign here. Okay, so who's, and you have written I. Okay, so basically what happened, it became a different name for I. So now even the same address, the 700 address is two names, I and K, and basically what will happen internally, it will say that okay, hey, K is also kept at 700. I'm saying again, see, we will write now one line. Okay, and in order to prove it, I'll actually, let me show it to you. In order to prove it, let me not write this J. Instead of this, I'm gonna write here, okay, let J be there because we already created it, right? Let me write here this K, and let me write here I. Okay, so here basically what is the value of K? K value is 10, right? But I'm doing here I plus plus, and actually I is getting printed. If now I print here K, okay, remember this is address. Okay, this is basically reference, like you can say this is reference variable. Okay, so I'm trying to say that okay, this is basically reference, which is saying that hey, now K is also pointing to the same address where I is pointing to. Okay, and if you're gonna make changes in one, that change will basically be reflected even in this. Okay, so in order to prove, let's see this, in this we'll be getting in both the cases 11. Okay, so let's see, we're getting 11. Makes sense? Actually what's happening is when you write this line here, okay, here this, it's like okay, you are saying K, ampersand of K. Okay, it means that whoever is after the equal sign, you go and actually mark that address as your address as K. That means K is also here itself. So now if you're gonna make here K plus plus, that means effectively you're trying to increase the value of I also, because now you can see that now this block of memory which is at address 700 has two names, I and K. Okay, I and K. Now you can actually make the changes. I hope this is making sense. Simple, right? Now you can make the changes. If I write here k plus plus, then if I do here k plus plus, so obviously first I did the changes in address 700, so it became 11. Previously it was 10, it became 11, and now k did the same changes at that same address, so it became 12. So now I'm gonna get 12 here and even 12 here. Okay, so let's see. Okay, understanding? So what's basically the use of it? Okay, let's first understand the use and let's see some things like some exceptions where how we shouldn't create it. Okay, but before that, let me tell you one use. Okay, so everyone have seen this. Like, let's say I want to increment whatever has been passed here. Okay, let's say n plus plus. Okay, great. Then you can do this. Let's do one thing. Let's not create these things right now. Okay, let me control Z. Let me actually do this like this. Okay, and I'm saying like, okay, you can actually do this increment, put the value I here, print the value I. I've received the value, I've actually increased it, but do you think we're gonna actually get the changes getting reflected here? Obviously no, because this n is basically a different variable and it's a different variable of increment function. This I is basically a variable of main function, right? So obviously changes will not be reflected. I will be printed as 10 only. Okay, so let's see, it's getting printed 10 only. Okay, so what's the use? You can do one thing, you can actually pass it by reference. Okay, as soon as you pass it by reference, okay, you're saying that, okay, I'm not passing by reference, you're passing the value, but you are actually collecting it inside a reference. That means you're effectively saying that, hey, n is basically, okay, this is this part, this whole part. Okay, you're saying that basically, hey, I is basically created at, let's say it's 700. Okay, I is created at 700 whose content is 10. Now I'm passing this value of I in my increment function. Okay, so main dot I, main I has value 10, and now you have increment function where you are trying to pass this value in your increment function, but you are actually passing it like this. Okay, so now in my symbol table, this has been created. You will even create an whose address is basically same as the I. And remember one thing here, as soon as you're passing int n, there is no memory that's been created for n. Okay, it's not like n is also created. Okay, n is actually pointing to the same, or you can say that n is now a new name of the same address 700. Okay, so now if you're doing n plus plus, here you will see the changes. Okay, let's see where we're seeing the changes. So let's see it. We will see the changes now. Okay, it should be 11 now. Okay, making sense now. It's simple, right? Okay, so these are some basic things that we need. Okay, throughout the course we'll surely be using these concepts. Okay, just trying to make things clear. Okay, as now. So now let me tell you one more thing. Let's say, let's not even call this. Okay, let's not even call this. You understood, right? Let's say I have done this. Can I do this? Obviously I can do. I'm saying in at line number 7 that, hey, hey compiler, you do this thing. What you do, you create first of all a memory I, and in the symbol table mark it as 700, and like there will be some garbage value that's not considered as of now. And in line number 8 I'm like, okay, hey, put the value of I equal to 10. So you're like, okay, I value become 10. Can I do in terms of reference variable? Can I do this? Let's see. We would not be able to do that. Okay, let's see, but let me just prove it. We will be surely getting an error. I can expect an error right now. K equal to I. Okay, we are getting an error. Okay, that means what does it mean? It means it's saying k declared as a reference but not initialized. That means as soon as you declare something as a reference variable, you need to actually initialize it, because k is actually gonna like go and become a new name of a variable, okay, in our program. So obviously we need to tell it. Okay, that means k is gonna take an address inside my symbol table, okay, whose address, whosoever is up after the equal sign. Now this will work fine. Okay, just the basic things. So now it's fine, it's giving me 10. Why is it giving me 10? Because I am trying to print the value of I, and I'm not doing anything. I'm just, even if I print k also, it will give me the same value. Okay, making sense? Okay, I hope it's making sense. Simple, right? So let's keep till here on this part. And one more thing, that this k, we are not creating any memory for k. Okay, what actually is happening? See, when there was int I equal to 10, int j equal to, let's say, 11, or let's say I, so I also was created, even j was created. Okay, but now I'm saying, hey, pass it by reference, then only k's entries marked as whatever is out after the equal to sign, so 700, and k also became a new name for this specific location, let's say 700. Okay, I hope this makes sense. Okay, so in the next videos let's do some more things, okay, like this only. Okay, so see you guys there. Okay, thank you.